Rational expressions are fractions with variables. For example, you could have 2x over 3, x squared plus 3 over 4x, or x over x plus 6. These are all fractions that have variables. In this video, we're going to work with these fractions. We'll simplify the fractions and then work on adding, subtracting, multiplying, and dividing them. To start off, let's simplify 5x to the 5th over x squared. We can split this fraction into two pieces. We can write it as 5 times x to the 5th over x squared. That groups our x's together. Our 5 we can keep the same. And then x to the 5th over x squared simplifies to x to the 5 minus 2, which is one of the exponent properties that we learned. And we can clean this up as 5 times x to the 3rd. All right, let's simplify. Negative 2x times x plus 3 divided by x plus 3 to the 3rd power. Let's take a step back and consider our previous problem. When we looked at this in earlier videos, we thought of this as x multiplied 5 times divided by x multiplied 2 times. And we could split this into two fractions so that these two x's cancel out with these two x's. That's where our shortcut came from. We're taking 5 of the x's and then subtracting out 2 to leave us with 3. That's the same kind of idea we'll use over here. In this case, we have 1x plus 3. You could think of this as x plus 3 to the 1st power. And then on bottom, we have 3x plus 3's. And we can rewrite this to get one of those x plus 3's to cancel out. So we could write this as negative 2x over x plus 3 squared times x plus 3 over x plus 3. If you multiply these two fractions, you get back to our step above. However, it's easy to see that one of our x plus 3's is going to cancel. In this case, x is just a number. We're multiplying it 5 times, and we're multiplying it 2 times. Over here, x plus 3 is just a number, and we're multiplying it once, and then on bottom, we're multiplying it 3 times. So it's the same idea. Just think of x plus 3 as a single number. If you do that, you can go straight to the answer. Simplify x squared minus 5x plus 4 divided by x minus 9 times x minus 1. So our first step here is to factor the top. I encourage you to try that on your own. And if you do that, you'll see that our expression factors into x minus 1 times x minus 4. Now we have an x minus 1 on top and an x minus 1 on bottom. So again, thinking of those as one number or one piece, we can cancel them out. And then we're left with x minus 4 over x minus 9. Multiply x over 7 times 2x squared over x. So we're multiplying two fractions, which means we multiply the pieces on top and the pieces on bottom. And doing that, we'll get x times 2x squared over 7 times x. And you can see we have an x on top and an x on bottom, so we can cancel those out. And as you get more practice, you'll notice that you can cancel in the very first step. You're multiplying two fractions, and there's an x on top and an x on bottom. So that saves you one step. And cleaning this up, we'll get 2x squared over 7. Divide 11 x to the third over x plus 1 divided by 22 x to the fourth over x plus 1 squared. Now how do we divide fractions? We multiply by our second fraction flipped. So this will be 11 x to the third over x plus 1 times x plus 1 squared over 22 x to the fourth. And now we're back to multiplying fractions. And you can see that we have an x plus 1 down here and two of them up here. So one of them is going to cancel. So we can cross out this one and then replace our piece up here with just 1 x plus 1. Similarly, we have 3 x's up here and 4 down here. So we're going to cancel out 3 x's. This guy disappears, and then we replace the one on bottom with just 1x. That's the x that's left over. And you might notice that 22 is 11 times 2, which means we can cancel the 11 on top with the 11 on bottom. Now looking at our top pieces, we canceled out this entire term, and we're left with x plus 1. And on bottom, we canceled out this term, and we're left with 2 times x. Let's add x plus 3 over x plus 1 plus x minus 5 over x plus 2. So now we're adding fractions. What do we need to do when we're adding fractions? We need common denominators. So if we consider a simpler example, let's say 2/3 plus 1/4, we need to get common denominators. We do that by finding the least common multiple of 3 and 4, which in this case would be 12. So our first fraction will multiply by 4 on top and bottom, and our second fraction will multiply by 3 on top and bottom. Doing this, we'll get two fractions with a denominator of 12. And to get a common denominator, you don't always have to find the least common multiple. You just need to find a common multiple. And a quick way to do that is to just multiply our denominators. If you multiply 3 and 4, you'll get 12, which in this case is the least common multiple. That won't always be the case. And back to our problem on the left, our denominators are x plus 1 and x plus 2. And to find a common multiple, we can just multiply them. So we'll have our first fraction, and we'll multiply top and bottom by x plus 2. And we'll have our second fraction, and we'll multiply top and bottom by x plus 1. Let's condense this into one fraction. We'll get x plus 2 times x plus 3 over x plus 2 times x plus 1. And on the right side, we'll get x minus 5 times x plus 1 over x plus 2 times x plus 1. As you can see, we have common denominators. So now we can just add the pieces on top. Now that we've done that, we need to FOIL each of these and then add up the pieces. Foiling the first one, we get x squared plus 3x plus 2x plus 6. And the second one, we get x squared plus x minus 5x minus 5. So now we need to add up our similar pieces. So we have an x squared and another x squared, which gives us 2x squared. We can cross those out. 3x plus 2x gives us 5x. And we have a minus 5x, so those actually cancel out. And we have 1x left over. We can cross that out. And then 6 minus 5 gives us 1. Our expression on the top does not factor, so we've simplified this as much as we can. Solve negative 2 over x minus 7 equals x over 5. So we have two fractions, and we're told that our fraction on the left is equal to the fraction on the right, and we need to figure out which value of x makes us have the same fraction on both sides. So let's think about this. If these two fractions are the same, then they should have the same denominator. Right now we have x minus 7 and 5. So how can we get a common denominator? We can multiply those two pieces. So we'll have our fraction on the left, and we'll multiply top and bottom by 5. And we'll have our fraction on the right, and we'll multiply top and bottom by x minus 7. On the left side, we have two fractions, so we can just multiply the pieces on top and the pieces on bottom, which gives us 5 times negative 2 is negative 10. Then on bottom, we have 5 times x minus 7. And on the right side, we'll have x times x minus 7 over 5 times x minus 7. Okay, we're a step closer now. We know that these two fractions are equal, so we got common denominators. Let's take a step back and consider a simpler example. Let's say I had a fraction, x over 6, and another fraction, that's y over 6. And what if I told you that these two fractions are equal? What could you tell me about x and y? Well, if these two fractions are equal to each other, and they have the same denominator, then they must have the same numerator. So x must be equal to y. So if y was the number 4, that means that x has to be the number 4. So we get 4 over 6 on the left side and 4 over 6 on the right side. We're going to use the same thinking on our problem over here. We have the same denominator, and these fractions are equal to each other, so they must have the same numerator. So our negative 10 must be equal to x times x minus 7. So now we have an easier looking problem. We'll distribute our x, so we'll get x squared minus 7x. Let's add 10 to both sides. So we'll get 0 equals x squared minus 7x plus 10. If you prefer the 0 on the right side, you can rewrite it. But now we just need to factor that expression. And if we do that, we'll get x minus 2 times x minus 5 equals 0. And this means our x is 2 or 5. And when you're working with fractions, it's important to check your answer in the end. We got x is equal to 2 or 5. But if we got, for example, x equals 7, if we plug that back in, that would make our denominator here 0. And we can't have that. You can't divide by 0. So if we got x equals 7 as our answer, we would call that an extraneous solution. And that's fancy math talk for doesn't work in the original problem. If you think about it, we started with this problem, and every step that we did here basically messed with it, and we just turned it into a different problem. And in the end, our problem looked like that. That's where we got our answer of x equals 2 or x equals 5. So an extraneous solution just says, when you messed with the problem, you got an answer that doesn't work in the original. So it's always important when you're working with fractions to check your answer to make sure it actually works. And one more tip, when you have a question like this, where you have two fractions set equal to each other, there's actually a shortcut to go from the original problem all the way to this step. And the shortcut is to multiply the numbers in the diagonals. So negative 2 times 5 gives us our negative 10, and then x times x minus 7 gives us this piece. So our shortcut here is to multiply diagonals.